All right, good afternoon, everybody. Thanks for joining our presentation here called Amp Up Your Brewery. My name is Kevin Weaver, founder, president, Brewmation. So pleasure to be here, and I appreciate the opportunity, Andrew, if you're still listening in the background. In this presentation, we're going to go over several things. We're going to talk about electric brewing, some of the misconceptions of perhaps electric brewing. Where does it fit in? Perhaps where does it not fit in? Kind of cover a lot of different things. So we're going to go ahead and get started here. And what we're going to take a look at here is, at first, is comparing our heat sources. Excuse me. What are the options out there to heat your brewery? Here's the three, ones that are typically out there. Of course, there's direct and indirect fire, electric, which we'll be talking about, and steam. So we'll kind of go through a few comparisons of the three and then kind of dig into the electric in some more detail. So the biggest question that most folks will say to themselves, well, how big can I go using the different methods? A lot of these are stats of what we see in the systems that have been shipped, so it could vary a little bit. But when we look at direct fire and indirect fire, typically we're seeing direct fire up to about 10 barrel. Once you're, have open flame in that, once you start getting pretty large, you're going to want to go to an indirect fire system. And those would be systems that would go up to about 15 barrel. As far as electric goes, what we particularly work on is anything up to a 15 barrel system. That's the biggest ones that we have built so far at 15 barrel. We kind of shaded the line out a little bit because there's no reason we couldn't do a larger system, but that really depends on what kind of power you have in the building. If you're able to provide more power, we've had a couple inquiries on folks that had some pretty decent power costs, so that was definitely an option. So we can go larger than 15, but that's the typical range that we would see. And then, of course, steam. We don't normally see them in small systems. I mean, you can do that. We've done a couple small pilot systems that were steam. But typically, when you're looking at a brewery, steam is going to, kind of start phasing in at 5-7 barrel as an option, or, a sensible option, I should say. And then it could go, as large as a brewery's needed. So a couple of which is the best. This is one, if you guys tuned in, we did another presentation. This particular slide kind of gives some comparisons, and just a little side note here is some of this is opinion based, and I'm sure that some people may have some disagreements or agreements, but this is kind of our best take at the different topics. But and it also depends on a lot of different things too. What your gas price is, what your electric cost, that kind of thing. But when we look at energy efficiency, direct fire is certainly going to be the least efficient, because with the direct fire, you're losing a lot of heat to the room. Pretty much, a lot of escaping heat. So your percent efficiency is pretty low. With electric, it's almost 100%, especially with the use of immersion heaters. With that, your every bit of the BTU is going into the liquid that you're heating. Steam is going to be probably number 2 in efficiency, definitely more efficient than the direct fire, but you do have some losses in the lines and natural losses in the burners, depending on the steam system that you get. Energy costs, it's not quite in line with that. You almost think that energy efficiency would fall in line, but when you look at some places with gas prices that are natural gas prices are pretty low, then direct fire may end up being a viable option, but a lot of times that kind of gets wiped out with the efficiency part of it. And also some folks might only have access to propane, so that could just then shoot that price all the way up. Electric, again, typically in the States, electric is a really good option, definitely compared to direct fire. A lot of times, cost-wise to run, it's very equal to steam. When we start getting into some higher cost areas, Caribbean, et cetera, the electric rates do get high, so it's something to consider. But steam in general really ties into your gas costs and propane costs. Capital cost, what is the lowest one to actually install? we gave a green on the direct fire. It's probably the cheapest to put in, but that does depend as well. It really depends on how much you have to do for makeup air, what do you have to do for gas lines, that kind of thing. Electric is definitely number two. Sometimes it is number one. If you have the power there already, then it's a pretty low capital cost of entry. The equipment's a little bit more expensive than direct fire just for the controls and all that, but installation probably makes up a little bit more compared to direct fire. Steam can definitely be a high cost to install. It may or may not be, but most times it definitely will throw some cost depending on if you have to build its own room. But steam fitters and that, there's quite a bit of work, the flues, etc. So definitely we put a red dot on that one. Fastest heat time. Direct fire, it is what it is because of the inefficiency. Sometimes, it's going to take a bit more on heating up. We kind of gave the electric a split dot there. It's certainly very good. We'll talk about a lot of that as we go through the presentation of what those times are, but certainly falls in line. It's one of the misconceptions about electric. A lot of folks think it's a slow heat time, but if it's properly sized, it's not. And steam is definitely a really nice way to go. It's probably the best in heat up time, depending on the size of your system. Response time to set points, etc. Direct fire, we got as a yellow, electric as a green, because again, we're immersed right in the liquid. So as soon as we change the output, then you get that very quick response. Steam, we got a red dot there just because there's a lot of latent heat that's in the jackets. So, if you're turning down a boil or that sort of thing, it takes a bit of time for that to adjust. The potential for automation, direct fire we have in there. We can automate it, especially some of the burners now with 0 to 100% control. We do that often, especially with indirect fire, actually, as opposed to direct fire. But yet it's not as consistent because airflow can change, your pressures can change. So if you're running that burner at 50% one day, it may be 40% the next day. Maybe not that bad, but you get the point. Electric is spot on. That's why we gave it a green dot. You put that at 50%, you're going to get exact amount of BTUs at 50% every single time. Just slight fluctuations with voltage, but not much at all. Steam we got in there as number two as a yellow dot better. And it depends on how you hook up your steam. Some put just solenoids on there. I mean, we happen to put variable position globe valves, so you're able to adjust and automate the steam as well. So overall, kind of simplicity. Direct fire is a fairly simple system all around. We kind of gave that a green and yellow, same as the electric. Electric, it is quite a simple process to understand. Steam, again, a little bit more complex when you get into steam traps and everything else. So it's kind of a nice screen here to get an idea of what you're going after. So here, consider all of the requirements. And, we have pictures of a bunch of trucks here. So what does this have to do with brewing? Well, just as an example, a 5-barrel direct fire brewery requires as much ventilation as 8 V8 engines idling in your brew house. That's something from the burner supplier, that they kind of use as a reference because it's important. So if you're looking to put into very confined spaces and that, it's definitely something to consider with direct fire. You have to get the right ventilation. You need to make up air for the burners to operate properly. So that kind of puts things in perspective. So additional things to consider. Direct fire, because of the efficiency, you're going to have to consider your brew house temperatures. It gets pretty hot in there when it's running because that's where all the inefficiency is going into the air. So you're probably going to have a bigger air conditioning system, or it's just going to be a hot brew house. Makeup air, as we just talked about with those trucks, is a consideration. Another big one is space around the burners. When you're trying to fit your brew house into the space, it has to be a consideration. It can make it tough to fit things, especially when we do layouts. We take a look at what that space around the burners needs to be, and that eats up quite a bit of space. The exhaust vent must be properly designed and professionally installed. We've had some folks, not do a professional job at that, and that's not the best thing. So it's a cost, it's a consideration, and you have to make sure you do that right for safety reasons. Noise of the burners. Direct fire is the loudest. When those burners are running, it's a pretty noisy brew environment. When you're running electric, you don't hear anything. Sometimes you get a tiny bit of a vibration sound, but for the most part, it's pretty darn quiet. Same thing with with the steam. Steam is pretty quiet as well, unless you're standing right next to the boiler, of course. But another one for direct fire, do you have gas or propane available in your location? If you don't have gas and you have propane, then you definitely want to take a look at what the cost is. Propane prices, well, propane and gas prices these days are all through the roof, but it's pretty proportional that propane is always quite a bit more than gas, natural gas. Electric considerations. Well, of course, what's the available power? We're going to go through that quite a bit, but do you have three-phase? Do you have only single phase? How much power do you have? What's the cost if you have to increase that power to your building? Sometimes the utilities will cover that cost. Are you going to double batch? Do you have some additional hot water requirements in the building? Spike and peak usage charges. Again, more to come on that stuff, but we'll go through it. Steam, cost of equipment, installation, maintenance that we talked about. Boiler room, check with the fire inspector. Sometimes it has to be in a separate room. Actually, quite a bit it has to be in a separate room, but it really depends on the area, so definitely check that out. We always tell our customers when they say they want steam, when you're budgeting, check the cost of pipe fitting. Try to avoid those surprises because it can get costly. And again, same thing, gas, propane, or even oil available in your location to run the boiler. And by the way, we can also do electric fired steam boilers, so that's another consideration. But then that goes back to the electric. And then also, if you're going to step in decoction mashing, when you start getting into some aggressive steps, and if you're looking to do a decoction, then steam is probably a nice choice. And typically, those are being done on larger systems anyway, so that kind of floats in there. All right, well, brewing with electricity. We all know this slide here, but where this came from. But we're gonna go ahead and go into brewing with electricity here. We'll first start talking about some of the myths. We've seen it out there that people say, well, if you're going to do a craft brewery electric, you need 300 to 500 amps of three-phase, 480 volt power. And who has that in the typical places for craft brewing? So that people say, well, I don't have that power, so I'm going to write that off. That's simply not true. The reality here is that craft brew houses in the 1 to 10 barrel range typically require 60 amp single phase on the small end for the 1 barrel. And it could be up to 200 amp three phase, depending on a 15 barrel is going to be more, but we'll go into that all of those power breakdowns. But 208, 240 volt power, that's the common. In fact, I do not think we've ever done I think we did one 460 volt electric brewery, and we've probably done, I don't know, at least 1,200 electric breweries. And they all been 208, 240. So that's the myth we wanted to kind of bust there. So some power requirements. Let's take a look at what you actually do need. And this is a slide that is showing if you only have single phase, what you would require. As you could tell by the slide, 7 barrel is the highest you can go with single phase. And here's the amp breakdown. If you take a look there, you got 2 bars coming up. You got a darker gray and a light gray. The darker gray is if we interlock so that you cannot run the hot liquor tank and brew kettle at full power for both at the same time. Light gray there is allowing you to do so. And we also have interlocks that you could do in between. So you see that all the way up the 7 barrel. If it's single phase, it's actually going to be a bit of a lower wattage than typical at 40,000 watts, and that's going to get you 200 amps. So once we get into the 3-phase, you see the comparisons. It's right next to the single phase. We can get, we lower those amps. Don't get that confused with cost typically. Just because you're running low amps, it's still the same amount of kilowatts, which is what you get charged at. But because of the higher voltage, it does drop the amp load down. It will save you a little bit on install perhaps, but it's pretty much comparable. But will allow you to run a lot more power to the different systems. So if you take a look at like the 7 barrel, You can get away with 150 amp if you're going to be running a 45,000 watt system. 7-barrel will also go up to a 200 amp if you're doing a 60,000 watt, which is what the 10-barrel is. So we'll show you some 7-barrels at the 60,000 watt option as we go through. And then you have the 15-barrel, which you see the little bit of a break in the bar there, is because you're looking at 325 amps as a typical 15-barrel system. That's if you were interlocked between the hot liquor tank and kettle. And we do that over 2 feeds. So it makes it a lot easier for folks who have the 208 volt 3-phase, where they will typically not have a 325 amp feed coming in. Some do. We even have the option for a 600 where you could run both at the same time. We're currently building one of them now. So the customer happens to have quite a bit of power there, so it works out well. But if you only have 225 amps as a max that you can do, but you can do 2 feeds coming in, then that's not a problem. We split that up for the 15-barrel. Myth number 2, an electric brew house is slow to heat, resulting in a longer brew day. Again, not true. A properly engineered electric brew house will be balanced to your process and shorten your brew day. So we'll show this to you. Here's a nice slide that shows some of the heat up times between the gray, which is the hot liquor tank, and the green, which is the kettle. The primary thing that we're doing here when we put these designs together is we want to make sure that the heat up time from doing your sparge temperatures in your kettle by the time you turn that kettle on to start heating as you're sparging into it, that you're in there by the time you're done sparging. So once you have your complete volume in that kettle, which is typically going to be an hour or under, we want to be at a boil. So you're not sitting there waiting for everything to boil. So if you look across the board there, you see all the green bars are under that time. When we start getting into the 10 and 15 barrel, you see the hot liquor tank heat up times are a bit higher at 75 minutes. But there's ways to shorten that as well, which we'll get to the next slide that kind of shows a little bit of that as we go. So here's a typical brew day. A lot of things can vary here, so this gives you just a real good overview. Time it takes to heat your strike water, and of course, just your water's maintaining or increasing for your sparging. Your mash in time, recirculation, and Vorlauf. Some people may run that longer or shorter. Your lauter time, and then you see that green bar that's kind of overlapping with the lauter time because once you are having enough volume, you're going to start your heaters and get boiling. Then you have your boiling time. Of course, if you do a longer boil, it's going to be a longer brew day, and then a typical whirlpool and transfer through your plate heat exchanger. And of course, you have cleaning after that. But this is a pretty typical brew day. In essence, no matter which way you're going to be choosing for your heat source. But one really neat way that we can shorten the brew day, I'll just show this slide here. What's nice with electric is you can put a timer on the hot liquor tank. So if you have the timer on the hot liquor tank, you could set that to be heating before you even come into the brewery. Or if you have it hooked up to a system that allows you to access it, like our advanced systems do, you can come in and turn that on prior to going to the brewery. So that cuts a whole good hour, or if you're on the bigger system, it's going to cut good 75 minutes off your brew day. Then of course you could keep your hot liquor tank always heating if you're brewing quite a bit. So that's obviously another choice. But the hot liquor tank timer for electric is a real key. You would not do that for a direct fire, and you would not typically be doing that with a boiler. It depends. Sometimes you're allowed to run that boiler while you're not there, but most times you cannot. And then here's just a kind of neat slide just to show you that you can get some pretty good production through with a electric brewery. And this is just showing an electric brewery that has a mash filter press and a whirlpool tank in the system. So as you can see here, you can have a pretty short brew day and actually do 3 turns of a brew day with an electric system, and of course with a mash filter press, just because of the way the brewery is being run. So you can really amp up your brewery by doing a lot of these things with the timer and also with a filter press. Myth number 3, electric elements will scorch my wort. Well, they will if you're not doing things properly. So we'll go into what is properly done. So modern brew house controls use ultra low watt density elements Basically what that is the surface area of the element based on how many watts are going into that element. So you want to spread that out, just like if you had a gas burner that was concentrating on one little spot in the bottom of your kettle, you're going to scorch. But when you have low watt density, that's being spread out enough that you will not get scorching. And one of the real big ones is to have a true 0 to 100% power regulation to minimize the risk of scorching. So we'll go through what that means here, but that allows you to set, if you want to run the burners at, the electric burners at 32%, you just type in 32%, it'll run at 32%. You want to run it at 60, it'll run at 60, anywhere between 0 and 100%. So this is the difference here in shown in the slides. You got, the evolution of the element control. So you have ones that you turn the power on. If you have 3 elements in this case, which is 18,000 watts, or 45,000, depends on which elements that you're using in there. Then as soon as you turn them on, you're going to get all 3 of those running. You'll get 18,000 watts. There's no in between there. The next one here is if you took those 3 and you turned off 1 element or 2 elements or 3 elements, you're going to have either 0%, 33%, 66, or 100. No in between on that. And then you have the way that is really the way to go here is a 0 to 100%. So no matter where you put it, those elements are going to be reducing in power, all 3 of them equally at the same time. So it's just the right amount if you have that 0 to 100%. So here's a good example that's been put together. If you consider a 7-barrel kettle with 3 15,000 watt elements, to achieve a 7% evaporation rate on a 60-minute boil, you're going to want 86%. That's according to the calculators. There's some things that can vary that, but it's an 86%. You're going to need 38.7 kilowatts. If you're using the on-off method, or the one that has that you just keep turning 1 or 2 or 3 elements off, you really have no choice. You're going to have to run at 100%. So here you're running at you'd have to run at 45,000 watts if you didn't have the 0 to 100%. It's a waste of energy, because you're putting a bunch of excess heat in there, but it's also really going to throw off your recipe. It's going to really limit what you can do, because it's going to, the boil off, your volume is going to change. If your volumes are changing, your hop utilization changes. So it really kind of pins you in a corner if you're doing the on-off, or you're just on-offing 1, 2, or whatever elements to achieve a slower boil. And it's also tough to regulate if you're just doing an on-off method, a boil over. If you're doing 0 to 100% starts to boil over, you could just turn it down a little bit, and that boil over is going to settle right down pretty much instantly. So, like I mentioned there, on a true 0 to 100%, you just set the power to exactly 86%. On our advanced system, you will actually type in 86%. On our more basic ones with a dial, you're going to set it between your 80 and 90% on the dial, and it's going to optimize your boil. And one other big consideration here is when you have that 0 to 100%, like in this example, if you're at 86%, you're actually lowering your watt density even further. So if you're running 86%, the watt density is a lot less. So you can almost call it an ultra low watt density element at that point. So really nice way to handle it. Some other causes for scorched wort, again, a misconception there, but one, you got to keep them clean. That is one of the things with the electric elements. Keep them clean with your CIP. A lot of folks out there do a CIP after the first brew, then maybe twist the elements in the tri-clamp for the next brew, so it hits directly more on the CIP that way. Maybe at the end of the week, just pop the elements out of the tri-clamp, give them a clean down. But the big thing is that you got to keep them clean, just like you're going to clean the rest of your brewing equipment. The residue, if there is residue on there, it's going to char the surface of the element, and that can lead to scorching. So again, the solution here is keep them clean. Element design is a real big thing as well. Not just the ultra low watt density. I mean, that's the first and foremost for the element design. But also when you're putting the element into the kettle, you're going to have a dead space in there where the tri-clamp meets the actual wall of the kettle. So you don't want to have a dead spot in there, because that's a place that you'll get some excess heat, and you're going to end up kind of cooking and scorching. I mean the dead spot in circulation. But what you want to do is actually put in our elements. Sorry, I kind of jumped ahead of myself. Our elements that we do, and I think some others may do it as well. We put a dead spot in the element. It's approximately 3 inches long. So that front side of the element that's in that dead space pocket will not heat. So that's a key. Another one is adding adjuncts. If you're going to be adding, sugar, lactose, whatever into the system, it's going to be the same as just about any other system. I mean, you're not going to want to just turn off the heat and then just pour them in there and then turn the heat back on without any kind of circulation. When we have some folks ask about doing it this way, you're typically going to maintain a boil. You're going to lower your heat down, but then you're going to be circulating. So circulate right through the your circulation whirlpool. Get a good circulation, get everything dissolved, then turn your heat back up. Another one is too much power. I mean, if you have too much power in there, you're going to be running it at 100%, then you're going to be at a higher risk of scorching because you're not lowering that watt density. So that infinity variable elements in the controls becomes very important. Some limitations is going to be if you're really going to be doing step mashes. You could do it with a Herms or rim system on an electric system. You're going to have some pretty decent times of changing your steps up to a 3-barrel system. Once you start really getting into some of the larger systems, depending on the elements that you have, it's something to be considered and could be challenging, or there's ways to work it out. There's another way to do it, which is to have a Brewery mash tun, which is a oil-filled jacket underneath that's heated by the electric elements. Power requirements, obviously, is a big one. It's not always a limitation, but you got to consider that. We talked about that in the beginning. So, you want to know that, especially if you're doing double batching, you want to ensure that you have sufficient power, to supply both the HLT and brew kettle if you're in a double batch. So, we do split up the elements. We have an interlock in there. So if you have a system that has 4 elements and you're going to need 4 elements to boil, it will, and you only have enough power to run 4 elements at a time. You're going to be able to split that just by turning both of them on. So in that 4-element example, you'll have 2 running in the kettle. So you're going to be doing some heat up in the kettle, and then you're going to be heating your hot liquor tank at the same time. In cases where we have some of the bigger systems and you are double batching, it would drop it down, say, to 3, so that you still have enough to boil in the kettle, and then you still have another element in the HLT, so you're heating up for the next batch. A couple example systems just to kind of run through here. Here's 1 to 3 barrel. You got your different options here of 90 amp 3-barrel single phase or 60 amp 3-phase. Another option, 125 amp single phase or 100 amp 3-phase. And the final option, if you want to run all 6 simultaneous, then we're going to run 200 amp circuit to the panel, single phase or 125 amp 3-phase power. 7-barrel system, kind of the same thing. You could run through this here, 200 amp 3-phase or 200 amp single phase. You could run 2 power feeds that will then enable you to run the hot liquor tank and kettle at the same time, all 8 elements. And we have different options in between. A couple notes down there, if you do have a rake and plow on a 7-barrel system, it might bump you up to 225. Single phase power will reduce your power to 10,000 watts per element, so that's 40 total. 10-barrel systems pretty much the same way. We're up to 225 because typically you're going to have a rake on there. And again, 2 power feeds if you want to run 8 elements at the same time. Last example here, well, there's 2 more, I think, but a 15-barrel system, you're going to have 2 power feeds coming in at 200 amp 3-phase and 125 amp 3-phase. So 2 power feeds, which will allow you to run 6 elements altogether. And if you run both at the same time, it'll drop it down to 3 and 3. We do have an option here, like I mentioned earlier, we are building one that is going to allow them to run all 12 elements at the same time, and that's going to require 600 amp 3-phase power at 208 volts. So is electric brewing right for me? Hopefully this presentation gave you the right things to ask for and think about as you make that decision. And I'm sure I didn't really leave a ton of time here for questions. I think my 45 minutes are up, but I'm just kind of looking on comments here. Let's see here. I think John has been answering some of the questions out there, but if you have any questions, please type them on in. But And also feel free to reach out to us, through our website. You can reach out to me directly, any of our sales folks. We'd love to help you out. Hope you found this presentation helpful, and definitely appreciate you joining. Thank you very much. Actually, I'm staying on. I just was told that I'm on till 5. I guess I was thinking I was 4 to 4:45. So we do have some time for more questions. So sorry about rushing through there for a bit, but if we have any questions, please go ahead and type them in. Well, I'll stick around here for a little bit, but it looks like John had asked about larger elements than the 5500s. And yeah, the element types there, just to kind of expand on that a little bit, are 5500 and 6000. The reason there's two there, 5500 watts are typically in the 208 volt category. And then if you have 240 volts, it's 6000 watts. If you kind of look at what, the resistance and all that kind of thing, if you try to run a 6000 watt one, it will bump up the wattage and overload the circuit. So that's why we have the two. And then the 15,000 watt elements, we do those in 208 volt or 240 volts. So it's always a 15,000 watt, unless you run single phase to it. And if you run single phase to that, then it's going to be a 10,000 watt element at that point. Rudad there has another question here. The typical power requirements for a 1 barrel, 3 vessel system. Yeah, if you're running that, a typical one's going to be 60 amps single phase. And if you had 3 phase, I believe it drops down to about 50 amps on that. And it depends. If you want to run both the hot liquor tank and the kettle at the same time, then you're going to look at 125 amps on a single phase. I think it goes down to 100 amp. It's definitely in one of the slides there, but yeah, that's kind of the two choices that you have. Jonathan has questions. Do any of your clients use solar to power or help power the brew house? Yeah, absolutely. We have some customers that do this fairly well. We have one 10 barrel electric customer that has had enough roof space to have a pretty big warehouse. They're running their entire 10 barrel system on solar power. Pretty slick operation. It works out obviously really well for them. Some strategies on solar that I've encountered is that, once you have solar panels, you're able to sell that solar energy back to the power companies. And if you have that ability to do that, they won't let you sell back more than you're actually using. Not all of them, some of them. Some of them, they let you sell back as much as you can produce. But what's nice here is that you could just put in, solar panels to sell back as much as you want, because you're going to have obviously enough load, to sell back. So that strategy has been implemented pretty successfully with a bunch of our clients. So yeah, it's a real good question on that one. Any other questions coming through here? Just taking a look. I think I pretty much answered all of them so far, but yeah, I'll stick around a little bit here. But just got a note here. I think that is all of the questions. Again, thank you very much for joining me here, and hopefully you found everything informative. I'm going to sign off. Have a great day. Thank you so much.